Hi everybody. First, just want to say I'm happy to be here, happy to be invited. Um, I'm Hendrik from Alpha Blues. We're located in Tallinn, Estonia, and we automate customer service chat using AI-based natural language understanding. There is a lot of buzz about chatbots in the recent months or the recent year, and customer service seems to be one of the use cases where actually chatbots are being deployed. So we have already deployed a couple of use cases for banks and fintech. So my aim is to give you an understanding what it means to build this kind of a system which tries to answer people's questions and also try to convey the idea that it's actually pretty difficult and natural language understanding is a big challenge. So if there is anything you remember from this session, then maybe it would be good if you remember that language understanding is fucking difficult if you want to do it with a computer. So first to start with, why automate chat? Chat is a growing phenomenon. So Facebook and WhatsApp both by now, this is an old slide, but by now both have around 1 billion users. And it doesn't seem like the growth will stop there. So it's more or less sooner or later that everybody is on some kind of a chat platform. And since people are spending more and more time in chat platforms, then this is also affecting enterprise. Enterprise used to get most of the customer information requests via emails or via phone calls. Now the amount of inbound they are getting via chat channels is increasing. And they know this, they see this, and they want to somehow enterprise wants to adopt to this with this trend. So they either have to you either have to employ new people to work on the chat, or you have to find a solution which where a chat is let's say half automated and the rest can be dealt with humans. Why customer service is a use case worth pursuing is because customer service expenses are very high. Swisscom is a Swiss conglomerate. They have many brands, but they say that their customer service costs per year are around 200 million Swiss francs. And Airbnb is a big company, and their customer service cost is around 30 million per year. So if you now imagine that maybe chat takes up of the from this amount maybe 20%, and then you automate then half of it, then it will be a noticeable sum. And the problem with traditional customer service is that as long as it's only done by humans, it doesn't scale well. It doesn't scale because a human can only handle one phone call at a time and around 5 chats at a time. But if you have millions of phone calls or millions of chats coming in, it just the cost will be prohibitive. And now it's time for AI to come to the rescue. But let's say the story is not just happy weather and sunshine. It's a lot of work. So understanding chat or understanding text starts from words. And it's maybe useful to know what is the base vocabulary. So it is safe to say that around 5,000 words should be enough to make, to give you a freedom of conversation in any context. While the minimal amount of words, what you can use to make yourself understandable is a few hundred. So this is perhaps pretty surprising that with a few hundred words, we can actually come across without looking too dumb. And if you look at the word usage statistics, then here you can see the most like in different contexts. The depth of the vocabulary, what is being used, is different. These ranks basically mean that what is the what is the frequency of the median word, what is used in newspapers in the distribution of all words. So let's say we have 100,000 words, then the median word, which is like with a frequency in the middle of its frequency distribution, gets around 1,500 rank in this total distribution. So you could say like maybe newspapers use around 3,000 words to convey the message. Books use around 2,000. And now if you go to television, you see that there is a big drop. So in TV, if you use corpuses from TV to train your models, for example, then the number of words you encounter there, or these, you will mostly encounter very frequent words. And the same is adult speech. I think this is most interesting, that actually we don't need that many words. Take 1,000 words and you are good to go. You can get along with your friends and spouses, and you don't really need all those 5,000 or 10,000 other words. But words is sadly not enough if you want to understand language, because words are not what they seem to us. And this is like, there could be millions of examples, but this is an example where there are actually two words which denote one concept, and the concept is the polar bear. But what I've put up here, none of those things. One is an image of a polar bear, the other is just a Wikipedia quote, and there was much more information about the polar bear. So the polar bear is something much bigger, something very different from these two words. And the trouble with chat or any text is that if the information comes in, we just see the words, or the computer just sees the words. It has no clue about the meaning or the relation of this concept to all the other concepts in the world. And so I like to use this analogy for the concept. So concepts are hairy creatures with many faces and difficult to contain. It's really very difficult to put your finger on something like, is the concept just the definition, or the relation of this definition to all the other definitions, or its position in a hierarchy of different concepts. Really, it's something in our brain, but the surface representation is the text. And one peculiar, or let's say useful characteristic of concepts is that they are related to each other. Concepts can form hierarchies. And hierarchies, like in science, where you can classify living creatures according to, or let's say, into different nested sets or classes. Or you can make up yourself any kind of a conceptual hierarchy you like. And the good thing about conceptual hierarchies is that they give you a reasoning or a rule-based reasoning system. For example, even just looking at this and knowing that something is an animal, you can tell, okay, it's not a plant, it's not a digital life form, it's not a closed shape. And this kind of reasoning is very powerful, because just given very limited information, you can already make valid inferences without having been taught those inferences. You just have the rules, and you can take it from there. Sadly, if we take the language understanding what we have in the computer, then these relations are not there. And here I've tried to draw or illustrate how the computer sees the message coming in. Where is my money is the most frequent customer service question from to banks and fintech. It's like maybe 10 times more than any other question, because if you don't have the money, if your card doesn't work, if the ATM just swallowed your card, you are really pissed. And this is the first question. And so in the computer, you would code it using one hot encoding, as basically each word is a different symbol. But now if we try to behave or think like computer, or see this encoding through our own eyes, then of course there is no meaning. Each word is just a symbol, or I chose squiggle, so each word is just a squiggle. And so now try to understand that this means that the person does not have money and wants to know how his or her card will start working, or why the money has not been transferred to her account. It's kind of, it seems almost impossible. But the way it works, or the way you can get this working, is that if you have a lot of these squiggle patterns, then you can make some generalizations. You do pattern matching, and you arrive at a solution. Basically, you have like a posterior distribution where you say, given these squiggles, I think that there is 60% probability that the person is asking, where is my money? And there is maybe 30% probability asking, I lost my card, and stuff like this. So just purely by pattern matching, without any semantic knowledge, based on the training data or the patterns in the training data, you can emulate understanding. And then that's what we do at the moment when we develop, or when we deploy a chatbot. We call them virtual customer assistants. And by the way, we never we encourage our customers not to think about it as artificial intelligence, but just as an agent which automates the service. We do not use the word artificial intelligence because if you say to people, now you have a powerful artificial intelligence-based chatbot, then they expect the bot to understand everything they say to it. And then the bot fails miserably very fast. So we downplay the expectations. We more or less say the bot is very stupid, but it's just supposed to answer the questions what it knows about, and let's take it from there. And then this is just an illustration of pattern matching. Basically, you are just going across an array or a sequence of some symbols, and you have trained some weights which you can use them to extract patterns. And if the pattern matches, then you get the higher value in the next layer, and you can take it from there. Maybe you can use it to predict what was the intent or the meaning in that message. Now, the next level, this is what we're working currently on, and which is the difficult part, is actually trying to lift language understanding from the token level more to the semantic level. So the assumption is that different words, let's say synonyms, are words where they are somewhere located in the semantic space, and they occupy there a bit of the semantic space, and you hope that words with a similar meaning, they somehow overlap in the semantic space, and these, you want to be able to use this overlap in order to generalize, so that like here are the examples. In the first two examples, the meaning is very different. I can't get money, I can't get satisfaction, but token level similarity is high. So if you take a token-based system, it would be very happy to classify, if I write to the customer service agent, I can't get satisfaction, then it answers me, okay, how much money did you transfer, or something like this. And the second, in the second example, the token similarity is very low. Basically no words overlap, but the meaning, I can't get money, my funds have not arrived, it's more or less the same. So the challenge is to make the system, which has only seen the first sentence, understand that the second sentence actually means the same. And we've been working for this now for a couple of months, and there are first indications that it actually is possible. It's not easy, but it's at least we can see hope in the end of the tunnel. And why this is a problem is because when we deploy our chat systems, we always have very little data available. This won't be a problem if you have a lot of data available, because like if you have 100,000 messages and each of these has been labeled according to the meaning or the problem at hand, then already token-based information will give you enough information to make very good predictions, because all of the combinations have been entered into the training data. We start our bots using training data around maybe 1,000 or a couple of thousand examples, meaning that the bot is trained on a very small amount of this possible the input universe, so it's very easy for the bot to make mistakes. And this is the general like the general scheme of how our systems work, or how any customer service agent, automating agent works. That you map a number of questions to an intent, which is the meaning, and intents have with it the intents have associated answers. Basically, you only want to respond to issues you can actually do something about. So when you start a project to develop an automated customer service agent, then you take the problem space, you divide it into different bits, and each bit should be a problem which we can actually we can give a satisfactory answer, or we can somehow help the person. Otherwise, there is no point. And in order to get to this, to have this functionality, in order to fake understanding, natural language understanding, then you have to go through all of these different input processing, intent classification, and workflow building steps. So it's not an automated process. Since different companies have very different problems, then you need to you really need to tailor the content and also the behavior or the business logic of the bot according to your customer. And here we have I have just highlighted all kinds of different pieces and bits which need to be handled if you want to have a chatbot or let's say an automated chat agent responding to people's problems. It's a lot of different stuff. And of course, a big part of this is language processing. Just the fact that there are different languages means that you kind of have to start from the scratch with every new language. If you do just token-based intent classification, then it's a bit easier because tokens are just symbols, and the learning algorithms, you just train a new algorithm for each language. But if you want to bake in some semantic information into these representations, then with each new language you have a setup, an independent time for setup, and of course if you actually if you want to sell this to a customer, then you need to show them something. A machine learning model is not, you cannot show it. You cannot show a matrix of weights or even I don't know, a blob of TensorFlow code. It doesn't impress people. So you need some UI where you can which you can use to enter the content and also get some feedback about the how the system is doing. And so just a few captions for managing the content. We have devised a JSON-based like domain-specific language where you can define the actions which the bot should take, then the intent category that it matches, the responses and routing to other actions. So you have like this kind of workflow routing logic and also markup language. Then you have a UI to which actually produces these JSONs. But if you want to have people entering the workflow logic, then you need to have a UI like this, or something similar. And you also need to work a lot with the data. If you do intent classification, you need to label by hand at least some of the training data. Usually we label a couple of thousand examples. And when the bot is in production, you also constantly want to, if you can log the information, sometimes we are not allowed to log it, but when we can log the chat history, then you can use this chat history to just increase the amount of training data. And this will gradually help your system to get better. And of course, you need to provide analytics, because analytics is in the end like basically this one number there solved by bot. This is the only number what you will be charged by the customer. So if a bank orders from us a virtual customer service agent in Facebook Messenger, then each month we report these numbers, and around 14 to 20% of closed tickets, autonomously closed tickets, is very good. It depends, of course, on the topics, what the bot can cover. Sometimes the bot cannot answer the question because it needs some integrations, or let's say the bot cannot do work on your account. This is always only people from the bank can do it, so we have to forward it. And another thing what is not seen here is that at the moment the way automated customer service agents work is that the bot tries to solve the most high volume problems which it is possible to solve. Some problems are so complex that only humans can take care of this, and they get immediately forwarded to the customer service representatives. Or if we understand that in the middle of the conversation we are not really helping the user, then we also forward to the customer service agents. And the usage statistics is another important part, because the content in customer service is quite fluid. It probably also depends on the company, but since services evolve, then also the topics evolve, which are important to solve. So that means that the customer service is sadly not, even the automated customer service is sadly not a hands-off affair, but you actually have to constantly update the topics, the intents, the answers based on what is happening with the company, especially if we are working with startups. Then this is especially intensive, because startups are continuously changing the content of the service or some mechanics within it, and that's how we have to adapt to. And this is all. So this is our team. We are 3 people. We've managed to put this the whole thing together, the back end, the front end, in around 1 year. We have a couple of paying clients, and we have also been lucky to have some coverage and collaborations with NVIDIA. And with this, I'm finishing. Thanks.